Time, hitherto considered as a railroad track that goes infinitely in both directions. Isaac Newton gave us the first mathematical model of time and space in his Principia Mathematica. But there was a contradiction. Why hasn't everything that was going to happen happened until now? In particular, why hasn't the universe reached thermal equilibrium? Einstein's theory of relativity says that mass and energy curve space, and one cannot curve space without involving time. Thus, time has a shape. In Newtonian theory, one could ask what happened before the universe was created. But in general relativity, time and space cannot exist independently of universe or each other. It would make no sense to ask what happened before the Big Bang, as such times won't be defined. In other words, time had a beginning at the Big Bang. To describe how quantum theory shapes space and time, we should introduce the concept of imaginary time. Imaginary numbers are a well defined mathematical concept. Consider the equation x squared plus 1 equals 0. This equation has no real solution. X squared equals minus 1, but there exists no real number whose square is negative. Therefore, x equals square root of minus 1, and we can say that x equals iota. Consider imaginary time perpendicular to real time. Imaginary numbers are imaginary, but this does not mean that imaginary time has nothing to do with real world. Einstein's general theory of relativity combined real time and three dimensions of space to a four-dimensional space-time. One can move freely in three space dimensions but not in the time dimension. One can only move in forward direction in real time. On the other hand, as imaginary time is perpendicular to the real time, it acts as a fourth spatial dimension. Consider an imaginary spacetime that is a sphere, like the surface of the earth. Suppose imaginary time was degrees of latitude. Then history of the universe would begin at North Pole in imaginary time. North Pole is a completely regular point and all the laws of physics hold there. Therefore, in imaginary time, laws of physics would not break at the Big Bang singularity. This was about a different view of time than the one we are familiar with.